Okay, so here I have the model for our decision problem. So we have the input data that was given in the description of the problem. I have the uncertain input. I have the mean and the standard deviation for demand. I have my decision variable, so it's the order quantity that then, based on the fact that each crate includes 4 gallons, I can calculate the actual stock of 600. Okay. Here I have the demand, which is uncertain, so I just place 600, but that number actually from week to week, it can change. So we don't know exactly what is going to be demand on that particular week. Then we have the units sold, the revenue, the cost, the refund, and the profit. And the logical equations that I use to calculate those things are given here. So the total cost is going to depend on my order quantity and the cost per gallon. I need to multiply by 4 because the order quantities are the crates, not the actual gallons. Then the number of units sold is going to be the minimum between the demand and the stock that I have at hand. Okay, so it's tempting to think that the number of units sold is demand, but that's not true, because if demand is greater than the stock, I cannot satisfy demand. I'll have some unsatisfied customers. So the unit sold is going to be capped or limited by my stock. The revenue is going to be based on the number of units sold, and then the refund will depend on whether or not I have any leftovers after the week. So if the stock is greater than demand, I'm going to have a positive quantity here, and that is going to be multiplied by the unit revenue. And then the profit is just the sum of the revenue, the refund minus the cost. Okay, so here we're going to be using a risk. So I already opened a risk here for my demand. So I have a working model. So if I change here numbers, my figures get updated. So that is good. Going back to 600, just to put a number there. And I'm going to define that as an uncertain input in my model. So I go to define distribution. And here at risk gives me what are the options. Some of the options. These are, the most common. Then if you look at continuous, you have all the continuous distributions that you can pick from. So we have a really big selection. I'll pick the normal distribution, select the distribution. And here it tells me what are the inputs or the parameters for that distribution. So yes, the mean is 600, that's correct. Here I need to update that, that should be 80. And the static value, if I want to give it a value, that's okay. I'm not going to update that. It picks demand as the name, that's perfect. So I'm done in that sense, so I say okay. The next thing I need to do is highlight what is my output. So I have here that the output is going to be the profit. So I come here and I say highlight that as an output. It gives me the opportunity to check the name. I said okay. And now if I examine the formula, what it did, it added this risk output function at the beginning of my calculation. And that's just to indicate that this is an output. Okay, so in that sense, I'm done. What I can do now is run the simulation. So here I can tell at risk how many iterations I want. I'm going to put 1,000. I'll do just one simulation and then I'll say start simulation. It's working, and here it shows me the distribution of profit. So right there I have the distribution of profit. Here I see that there is a long tail on the left, and there is some cases where the profit is negative. I see that it has a big peak or tall peak here around 420. 420 is the maximum. So, and that is sort of fixed or determined by the fact that I cannot sell anything more than 600 gallons. So when demand is greater than 600, I lose that demand and the only thing I can do is just sell 600. I can ask Risk to give me a report of the results. So if I click here and say quick report, I can get the quick report. It creates another file or another tab that has the information. So if I want to, so here, if I want to save those results here in my spreadsheet, I can do that using functions from a Risk, like Risk for the average profit, it will be Risk mean, and then I highlight profit. Or Risk standard deviation, Risk standard deviation, and highlight that. And for calculating the probability that profit is less than 0, I can use another function in a Risk that is called Risk target. Target is, so I need to put that and put, I cannot get it right. All right, so this is telling me that the probability that the profit is less than 0, so it's negative, is roughly 4.5%. All right, so these are all the results or all the information I can gather for one order quantity. It will be more interesting for us to have what is the expected profit, what is the standard deviation, what is the profit of getting a probability of getting a profit that is less than 0, if we could change the order quantity and save that information. For that, we can create a table and we can use the function in a Risk that is called Risk sim table. So what I'm going to do, instead of putting 150 there, I'm going to use that function, this Risk sim table, and then I'll highlight the values. Okay, so now it picks the first value that I have there and put it inside my spreadsheet. And then I'm going to write here, these are going to be different simulations. So I'm going to ask a Risk to run different simulations, one with 130, the next one with 135, and so forth. So I'm going to come here on the top and I'm going to indicate that actually I don't need one simulation, I need 7. I need a 1 with each of those numbers. So now I'm going to just start simulation. All right, so that was it. That's what it did. It quickly did a simulation with each of those quantities. And here we can see the distribution, and this is for simulation 1. Simulation 1 was the one that had an ordered quantity of 130. If we come here, we can change that to simulation 2 and see what is the distribution. And we have here the mean, the standard deviation for this simulation. Let me pick another one. So I have here simulation 5, which had an ordered quantity of 150. All right, so I'm going to close this here. And I'm going to add in my table the average for each of the simulations. So I'm going to use Risk mean for the profit. So I'm highlighting the profit and I'm letting it know that it's for the first simulation. That way I only get the average of the first simulation. Now I'm going to do the same for the standard deviation, Risk standard deviation for the profit simulation 1. And now I need Risk target, profit again, and the target value, and simulation 1. I actually don't remember if it is in that order or I need to put it. need to put here risk target first, type it correctly, and that's it. Okay, so right there I have what is the probability for that one. And I'm going to put $signs for the references for the profit because my results are stored in there. That's the output. But now I'm going to drag that to the rest of the table. That way it's updating the results. So here what we see is that, okay, the expected profit or the average profit based on 1,000 simulations, so this is sample data, is 343. If we increase that to 135, the average profit increases. And then if we keep increasing, it goes down. We can also see what happens with the standard deviation. So the standard deviation, when we order little, is low, but then it starts increasing. And we can also see what happens to the probability of having a negative profit. In other words, to losing money on a particular week. So now the decision maker can look at this information and now make an informed decision. And depending on the attitude of the decision maker, he might pick a decision that has greater expected value with the lowest possible standard deviation, or maybe he'll still pick a decision that has higher standard deviation with the hope of getting a higher profit in a particular week.